So what we haven't covered yet is scientific notation, and we haven't talked much about polynomials either. So today we're going to do scientific notation, maybe a little bit with polynomials. Next week we're going to finish up polynomials, and then we'll go over any questions that you have on that practice final. So your homework for next week is going to be go through that practice final. We have done most of them. Any of them that you're confused about, like the applications, maybe one of the interest problems, ask about it, and we can go over it again in class if you're still confused. But we need to go ahead today and talk first about scientific notation. And this is a very, very easy topic. And scientific notation, you'll find it in a physical science class. You'll find it in maybe a biology class, like a micro class. Scientific notation is used when you have either extremely large or extremely small numbers. So let's look at this. This is in standard notation, and we're going to rewrite this in scientific notation. So this is going to be in standard notation. Okay, so 300 is in standard notation, right? We know how to write that. No problem. We understand what 300 is. We can rewrite this in scientific notation. So let's see how we would rewrite this in scientific notation. So in scientific notation, what we do is we have our 300, and we want it to be one digit and then the decimal. So for scientific notation, we want one digit, then the decimal. So our decimal point is right here. So we want one digit and then the decimal. So we're going to have to move this 1, 2 places. And our decimal would be right there. So we can rewrite this as 3, and then we're going to use a times 10. And how many places did we move to the left here? We moved 2 places. So that's going to be 3 times 10 to the second power. So that's what it would be in scientific notation. So this is in standard notation, and this is in scientific notation. Let's try another one. How about minus 67.4? That's in standard notation. What would that look like in scientific notation? Well, in scientific notation, what do we want? Okay, we want one digit and then the decimal. You might want to pay attention. This is a very, very easy concept, and there's lots of questions like this on your final. It's an easy topic, very applicable to your science fields, so that's why I want to make sure that we cover it. It's easy, and there's a lot of questions on your final with this. How would I rewrite this now? Well, where's your decimal point? Right here. How many places do we have to move? We have to move one place. So in scientific notation, that would be a minus 6.74 times 10, and we moved one place, so times 10 to the first there. Because we moved that one place. You always want one digit and then the decimal. So let's try a larger number now. And let's convert this one. That's what would that be? That'd be 845 million. What would that be in terms of scientific notation? Well, we've got our 845 million, bless you, and at the end is our decimal point. So how many places are we going to have to move? Well, there's 3, there's another 3, and there's 1, 2. So that means we could rewrite this as 8.45 and add up the numbers below, and it looks like it's going to be times 10 to the what? 8th power. Okay. Is everyone okay with that? Now we can also go the other way. If we have a decimal, we can rewrite it in standard notation, in scientific notation as well. So this is going to be our number in standard notation. What would it look like in scientific notation? Well, what we want is we want one digit and then the decimal point. Now, if you move it to the left, it's going to be a positive value. If you move it to the right, it becomes a negative power. So where's our decimal? Our decimal point is right here, and we're going to have to go 1, 2, 3 places, and we're moving it to the right because it's less than 0, or sorry, yeah, less than 1, so it's a small value. So that would be 4.3 now, and that's going to be times 10. We move it to the right, 1, 2, 3 places. So that's going to be times 10 to the negative 3rd power. Let's do another decimal here. And let's convert this one. So here's our decimal point. We're going to have to move 4 places over. One more makes it 5. So what would that be? Now the negative stays with it. So that would be a minus 8.64. And that's going to be times 10 to the negative 5th power, because it has to be one digit and then the decimal. Now let's go the other way. Now I'm going to give you numbers in scientific notation, and we're going to rewrite these in standard notation. So let's try a couple of these. So we're going to go the opposite way now. So this is going to be in scientific notation. What would this look like in standard notation? Well, it's 9 times 10 to the 4th power. So there's my 9, and this tells me how many zeros I have to add in. So I've got to add in 1, 2, 3, 4 zeros. So that's going to make it then, because we're going to move it forward 4 units. So that's going to be then 90,000. So 9 times 10 to the 4th. This tells me how many zeros I've got to add in. Moving it back then 4 places, that makes it 90,000. Let's do a few more. And this again is going to be standard notation. And then scientific over here. So let's do one in scientific again. Let's make it minus 9.43 times 10 to the 3rd power. What would that convert into? Well, we've got 9.43. Now the negative just comes along with it. So it's just a negative number. That's fine. No big deal. We need to take this then 1, 2, 3 places. So add in your 0. So that would be then negative 9,430. And that would be your number then in standard notation. Let's do one more that's positive, and then we'll look at some negative exponents as well. This one's going to be a little bit larger. This is scientific notation. We're going to convert this now to standard. How many places do we have to move? 6. So there's 1, 2, and then 4 more. So there's 2, and then 1, 2, 3, 4 zeros. So it looks like that's going to now be 64,300,000. Nope, let me write the correct number of zeros here. Sorry about that. There we go. So it's 6,430,000. Sorry about that. That's what your answer would be in standard notation. And again, these are very easy. You probably use these maybe in a science class. If you haven't, if you take Principles of Biology, you do a little bit with scientific notation in that course, and especially in like a chemistry class as well. Now let's go with a negative exponent. What would this one be? This is, again, in scientific notation. Now, it's a negative exponent up here, so it's going to be a decimal. If it's negative here, it has to be a decimal. So we've got 4.3, and we're going to have to move it forward 5 units. So here's my decimal. So 1, 2, 3, 4, 5. Okay, so it looks like we've got 4 zeros here and a 0 in front. So in standard notation, that would be 0.000043. Okay, so we converted those. Let's do one more, and then we'll start talking a little bit about polynomials. How about minus 9.76 times 10 to the minus 4th power? So let's convert that. If I try to convert that one, well, what's that one going to convert into? Now the negative still stays with it. And we've got a negative 9.76. And we want it the negative 4th, so we've got to go 1, 2, 3, 4. And we're going to plug in these zeros. And that negative comes down. So the negative still stays there. So it's going to be minus 0.000976. And I usually write the 0 in front. That way we don't make a mistake. Because a lot of times if you don't put that extra 0 in front, you'll lose your decimal point. So I always put that extra 0 and make sure we know that the decimal point's there so we can see it. So that's how you work with scientific notation. And there are several questions that involve scientific notation on your practice final. There's several of them on here. Like, these are questions I don't want you to miss on your exam. You've got 18, 19, and 20. See, these are ones I don't want you to miss. They're easy questions. 18 and 19, you just rewrite them in scientific notation. So you just move them over and make sure it's 1 digit and then the decimal. And 20 is the same way. All you need to do is rewrite this as a decimal. So those are 3 questions that you should not miss on your final. They're very, very simple, easy questions to work through. And on your final, I did give you a lot of just checking concept questions like those that are not really difficult. And I try to stay away from the really, really intensive problems. So on your final, a lot of those questions, there are a few that take some time to go through, but a lot of them are just going to be concept questions. So let's now talk a little bit about polynomials. And this goes back to the Greek word poly, and that means many. So we're going to be looking at things that have many terms. Okay, so these are all polynomials. 5x squared plus 4x minus 3. 8x plus 4. How about 9x to the 8th minus 6x to the fourth plus 3x minus 2. These are all examples of polynomials. Okay, so these are all polynomials. And polynomials is just a generic term. It just means you have something that has multiple parts to it. Poly means many. So when we look at these are all examples of polynomials. They have more than one term. And terms are separated by addition or subtraction. Now we have three basic types of polynomials to look at. We have a monomial. These are all, again, polynomials. Monomial, that means you have one term. And these are examples of monomials. 5, 8x cubed, 9x to the fourth. So these are examples of monomials. Mono means one. So these have one term. Each of these has only one term. Terms are separated by addition or subtraction. And there's three basic types of polynomials we focus on. Otherwise, we just call it a generic polynomial. There's monomial, there's binomial, and binomial means you have two terms. Think of a bicycle. Two wheels on a bicycle, two terms. So these are examples of binomials. 5x plus 4. 9x to the fifth minus 8. 7x to the fourth plus 8. We can use different variables, but let's just use the same one. Let's say 8x to the second. These are all examples of binomial. And again, I think of a bicycle. Bicycle has two wheels. Okay, so these are all going to be binomials. The last one is the trinomial. Okay, and when we talk about trinomials, these have three terms. And again, a classic example, tricycle. 3 wheels on a tricycle. Trinomial has 3 pieces. And these are examples of trinomials. 3x squared plus 8x plus 9. 5x to the fourth minus 8x plus 7. How about 2x to the ninth plus 3x minus 4? Okay, these are all examples of trinomials. Trinomials mean they have 3 terms. And so what again separates the terms? Addition or subtraction. So each of these is monomial because there's no addition or subtraction. Okay, so it has one piece. What about binomial? 2 parts, right? Addition and subtraction separates these. Trinomial means they have 3 parts. And there's also quintics and quartics, but we don't really use those very often. So we only look at these 3, monomial, binomial, trinomial. That's it. Anything else is just a generic polynomial. Now the degree is going to be the highest power. So the degree of the polynomial is going to be your highest power. So I'm going to give you 2 of these, and then we're going to see what the degree of these are. So all we're doing is classifying these. So what would the degree on this first one be? Well, on the first one, what's our highest power? Our highest power is 4. So that would be a degree of 4. What about the second one? And they may not be in the correct order. They may not always be the highest power first. So on the second one here, what is its degree? It's easy. It's a degree 12. 2 more examples. What would this one be? It's not 5. Okay, 5x, there's actually a 1 there, right? We don't write the 1, but there's actually a 1 there. So in 5x, it would have a degree of 1. And if it's just a number like 4, it has no x, so that would be degree 0. So when we talk about degree, we talk about the highest exponent. Now in intermediate, if you have multiple variables, they go together. But in elementary, we focus only on a single variable. So for the degree, we find the highest power, and that's going to be our degree. And if there's no variable, it's a degree 0. If there's just the variable, there's actually a 1 there. So that's actually degree 1. So there are a couple of questions on your practice final that we're going to look at that talk about the degree and also the classification of these polynomials. So when I look here, use my copy so I'm not writing on the extra one. When I look here at questions 22 and 23, let's talk about those. So on these, all we need to do is decide what it is, how these are classified, and then what the degree is. So what would this one be? Well, when we look at it, and it doesn't matter the variable for the degree. Now, our choices for the number of terms are monomial, binomial, trinomial, or none of them. Now, 1 term, 2 terms, 3 terms, or more than 3. When I look here, how many terms do I have in this first one? We've got 1, 2, 3, 4, 5. Okay, 5 terms. So it's none of them. So it's not a monomial, not a binomial, not a trinomial. What's my degree? Degree is the highest power, okay, and we've got a 4, a 3, a 1 there, and a 5. So that's y to the 5th. So my highest power would be 5. So what would that one be? It would be none and degree what? Degree 5. Okay, what about 23? What would 23 be? Well, how many terms do we have? 1, 2, 3. So this is a trinomial. And what's my highest power? 5. So what would it be? Trinomial with what? Degree 5. 2 questions like that are going to be on your final. So again, there are a lot of very simple questions that are just concept questions. Do you know what a polynomial is? Do you know how to classify them? We've got a little bit of time left. We're going to look now at how to combine like terms in these polynomials. So we're going to add and subtract them. We'll do multiplication next week. So we've got a few minutes, probably about another 5-10 minutes, and we'll be done here. But I do want to look at adding and subtracting polynomials. Okay, when we add or subtract polynomials, what we do is we want to combine like terms. So that means they have to have the same powers to go together. So variables that have the same power go together. And again, very, very simple, easy concept here. So when we add or subtract polynomials, variables that have the same power go together. And when we write our answer, we always want the highest power first. So this is just a polynomial, and we want to go ahead and add these together. We want to combine like terms. We want to simplify this down as much as we possibly can. And when we simplify these down, we want to look and we want to see what we can combine together. And we always write the highest power first. So when we put these together, the highest power goes first. So what do we have here? Well, it looks like we have an x to the 9th here. And that's our largest one, so it's going to go first. So we have a minus 8, x to the 9th. So that one's gone. So we're done with that one. And then we move down, and it looks like our next highest power is a 7. So we have a 6x to the 7th and a 7x to the 7th. They have the same powers, so these can go together. And 6 plus 7, well, that makes it then a 13. X to the 7th. Gone. Gone. Okay? And you can cross them off when you're done with them if you need to. I'm trying not to cross them out too much because I want you to see the examples here. What's next here? We've got an x to the 5th, and we've got 9 and minus 3. These can go together. 9 minus 3 leaves you with a 6. X to the 5th. Gone. Gone. And what's on the end? 3. So that's what I would want for the answer. Is I just want you to go ahead and combine them together. Now you may also have parentheses on some of these. So the same directions are going to apply to the next one. We're going to just combine them. And you might have parentheses, and sometimes they're needed, sometimes they're not. So these are our three different polynomials here, and we want to go ahead and combine them together. A lot of times you're going to have these parentheses and they're not needed. And the first and the last terms pieces, they don't need the parentheses, but the middle one, okay, we have this negative here. So that negative in this middle is going to be distributed through. And so what I like to do on a problem like this, when I have all these extra parentheses, I like to rewrite it without them. That way I can see what I've got and how I can combine them together. So we've got 3x to the 7th plus 5x to the 4th plus 3. Now this negative is going to be distributed through. So that's going to switch our signs. So now we have a negative and a negative. That's going to make that a positive 3x squared. Negative and positive makes it a minus 6x to the 4th. Negative and negative makes it a positive 9. And we don't need the parentheses here because of the plus. So that's a 4x squared, a 5x, and a minus 2. Now, what do we need to do? We need to rewrite this in as few terms as possible with the highest power going first. And work your way down. So what's our highest power? It looks like it's going to be this 3x to the 7th. And there's nothing else that can be combined with it. So that's going here. Okay. Now what do we have next? Okay, next it looks like it's going to be x to the 4th. So we've got 5 and a negative 6, so that's going to make it a minus x to the 4th, because 5 minus 6 is 1, and we don't have to put the 1 here. Gone and gone. Now we've got our squares. How many of those do we have? We have a 3x squared and a 4x squared. Adding those together, 3 and 4 makes it 7x squared. Gone and gone. Then we've got our x's, and it looks like all we have is a 5x, so that's gone. We wrote that down. And what do we have left over? Numbers are left over. So we have a 3 and a 9, that makes it 12. Minus 2 makes it now 10. So once I combine them all together, this is as far as I can go. I can't go any further because all the powers are different, and my highest power or highest degree is first. And this would, by the way, be a degree 7, and it's not any of the polynomials, so you would classify this as none. It's just a generic polynomial. So I just wanted to make sure we knew how to do those. And there is one question or two questions on your practice exam that has that on there. And we can find them real quick. Let's find one of them. Just so you see that it's on here. I think it's, yeah, there's a couple of them. Question 11. Okay, it's just like what we did. Almost exactly verbatim, just different numbers. So all you have to do is rewrite it and combine them together. Now you should be able to do almost all of these. There's only a couple of questions that we haven't covered. So just so you know which ones we haven't covered yet, they're all kind of grouped together. We have not covered question 10. We have not covered question 15 and question 16. And I believe that we've covered all of the others. Okay, so everything else should be covered. So let's now go ahead and quickly talk about our homework for next week. So what's your homework? Well, your homework is going to be 3.7, and you should be able to finish that out. Okay, you should be able to finish out 3.7, and there's no exam. So don't worry about that practice exam. So do not do the practice exam. So do not bother working out practice exam 3. So don't worry about working out practice exam 3. We just didn't quite have enough time to cover an exam over chapter 3, but they're in your final. There's a lot of questions from chapter 3 in your final. So don't worry about that practice exam. So your homework is going to be 3.7. Should be able to finish all that out. And then you should be able to do all the questions on your practice final. You should be able to do them all, but 10, 15, and 16. Now, if you work some of these out and you look at how I worked them out and you're still confused about them, ask next week. We've got plenty of time next week to answer any questions that you might have on that practice final. Okay, so what we're going to do next week is we're going to talk about foiling and multiplying these polynomials, and that's going to be our last major topic. And then we'll go over any questions that you might have on your practice final. And then our final exam is going to be December 15th. And on December 15th, I need to make sure I have all of your homework turned in that you want graded. Has to be done December 15th. I need to make sure you get this packet that I gave you today. Make sure you turn it in as well, because you'll get 15 points for working through that practice final. And then your take-home final is 100 points, and I'm going to grade that. Okay, so that's going to be graded. So make sure you get the correct answers on that. And then on December 15th, we're going to have our in-class final. And that is worth 300 points. but you're going to know exactly what's going to be on there. Okay, very important that you have the skills needed for the next class. And if you can do that final, you'll have all the skills that you need. But you know what's going to be on there. There's no questions you're not going to have seen before. You look at the practice final. Look at the take-home final. They're very, very similar. Use those two then to work out and get ready for your in-class final. So use that to make your notes off of those, your note cards or your page of notes. If you do that, you will do very, very well on your final exam. A lot of times when I give the final exam, most of you will get A's or B's because you already know what's on there, you've worked on it, and you've had 2 weeks to get ready for it. So that's what we're going to be doing next week, is we're going to be finishing up any questions over that practice final that you might have and multiplying polynomials, learning the FOIL method. And then you'll be ready for intermediate algebra next semester or whenever you choose to do it. Okay, so I will see everyone then next week, and we're going to go over our practice final some more.